Hello, my name is Benya, and for my AP Physics final project, I decided to touch on vehicular safety, more specifically focusing on SUV handling and flipping. Now, originally, I wanted to talk about combustion-reliant SUVs and how those have the tendency to roll over. Jeep. And then talk about EVs, which are roll resistant. But I soon came to realize some EVs have this issue, and since we're all supposed to be moving to electric cars by at least 2035, I thought we can talk about EVs. According to carstats.gov, 3% of all roadside accidents are caused by the vehicle rolling over. The percentage is higher for vans and semis, respectively. However, about 35% of all passenger vehicle fatalities are associated with a rollover or tip over accident. So, how does a car roll over? The driver losing control of the vehicle, maldistribution of weight, which can be a design flaw, and high speed all contribute to a rollover. In Newton's perspective, when a vehicle loses its state of equilibrium and undergoes a tipping motion, it will roll over due to the forces acting on the body of the car. And roll is generally defined as a rotation of 90 degrees or more about the longitudinal axis. There's also a distinct difference between longitude and lateral, which I'll get to later in the video, that will help us uncover the physics behind this. So how do we test a car rolling over? I wanted to do a demonstration with Legos, and though it worked on paper, the Lego tires had too much traction because of the lack of suspension, and I would have to make the Lego reach high speeds, which I just couldn't have done in my house. So what's the next best thing? Technikens-Wild. The Swedes come to the rescue once again. Let me introduce you to the Moose test. Originally conducted by Technikens-Wild, tested first in the 70s. They have since tested a variety of cars. More on the Moose test. The Moose test is a test conducted to measure a car's handling of an evasive maneuver. Mechanically, the test measures a car's handling ability and resistance to rolling over. The car is packed full of weights and people. Then the driver weaves through the set of cones that replicate swerving to avoid something in the road like a moose. Oh, and this test is frickin' aggressive. Now, for a car to pass the test, they need to be able to reach the speed of 43 miles per hour or 69 kilometers. Nice. Without having the rear wheel get off the ground or the car hit any of the cones. And for the cars that do pass the test, they just continue to run the test, simply increasing the speed to the point the car fails. Now let's go to the teaching wall for some teaching time. Welcome to the teaching wall. Before we get started, I want to clear up some misconceptions. The Moose test is in fact a real test. It is indeed standardized too, so this is the ISO number. You can go ahead and check it out. It has been conducted on many hundreds of cars, probably thousands. And so as we saw in the video, the Mach-E failed. We'll look closer to how it happened and try to drive an equation even. Okay, before we do that though, I want to go back to a definition I talked about and uncover some new vocab. First on the list is abbreviation CG. More commonly known as center of gravity. It is the average location of the weight of an object. And CG in this situation is given to us because though I was, after watching some videos and reading some articles, I was able to wrap my head around it. It wasn't something easy. So here that is. And then longitude and lateral. Longitude is anything lengthwise, and lateral is side. And we'll get to this very soon. Okay, let's go over what does it mean for a car to roll over, physics-wise. Basically, if a car loses its state of equilibrium and undergo a tipping motion, it will roll over due to the forces acting on the body of the car. And here, this is the Mach-E. We can pretend it is. It looks a little weird because I wanted to emphasize on the suspension. We see this is the body, this is suspension, this is the rear differential, like me and my grandpa like to call it, otherwise known as an E axle in an electric vehicle. And finally, the wheels. Okay, so center of gravity, we have force of gravity pulling down on that exact point. That's why it's called center of gravity. And then what the axles are doing, they're not sure if you can see it, but here I have two arrows pointing to the wheels. Load transfer. That means at this point, the normal force on both wheels is equal. So this is what before they even go to the cone area. So it's just like traveling forwards. And let's take a look at B. So before we actually talk about where this is, I forgot to introduce something here. This is this whole body, the body of the car, the axle, everything rotates on this, which we will call a point O. That will help us here. So in this situation, the Mach key is either right before the instant it fails the test, which means right before the rear wheel gets lifted up, or it might be during. Now I want you to take a look and see if you can figure it out yourself. So we have AY, the lateral acceleration. So, you know, it is currently in the term, and because we have AY, we have two forces that are canceling that acceleration, which means in the y-axis, we're actually in equilibrium. Are we in equilibrium in the z-axis? That is yes. So this is actually right before Mach-E fails the test. How does Mach-E fail the test, you might ask? Well, that's simple. This lateral acceleration will increase as it is turning, and when that happens, more load transfer, load balance gets disrupted, meaning the normal force that the right wheel experiences is far greater than the left wheel, and to a certain point, the left wheel will actually not have any normal force at all. And at this point, ladies and gentlemen, the car is no longer in a state of equilibrium. Which means the car has failed the test, which means that this is how a car rolls over. Now, let's use the free body diagram as a base to derive the equation. Hello, welcome back. Let's write the equation now. So I wanted to say two things. Firstly, it's over here. It's actually a lateral acceleration times mass, and let's write the equation. This is where the second things come in. Probably should have made this to the left, but right is okay. We, in physics, at least in our class, we usually say this is positive. In this case, it would be negative. And so when putting everything together, we'll get negative times, this is the destabilizing part, AY, which is lateral acceleration, times height of center of gravity. This is very important. I kept this here so that we know that it's staying the same. H, C, G, and then we add the positive, the stabilizing factor, which is every single one of these. So first we have the normal force. we have F normal, right minus left. Oh, and this is our classroom mascot, Mr. Shoebill, the Shoebill Stork. We'll have to move him because I thought we didn't need this. Here, we'll bring him here. F force normal left, which is this one, and then times LT transfer over 2 minus M, because again, probably shouldn't have done it that way, times G, 9.8 in this case, and then, okay, so we have to do theta, and theta is basically here. So theta, and then HCG, and this term you can make it basically sine of theta. That's how you can get it. I'll just keep it at this. And this will actually equal 0. So if you do this, you can find out the last instant where the car is still at equilibrium. And then finally, we can actually put this on its side and just say M times AY, so broken marker, times HCG equals normal force R minus F normal L times LT over 2 minus M times G times theta times HC. And with that, I'd like to conclude our lesson. I hope you learned as much as I did. I definitely learned a lot, and I'm sorry if I bored you. Have a good night. It's currently 4:41. I've got this work done. I've got all my footage ready that I need to edit in. And there's the definition sheet. I'll have to cut that. My script is ready, and then we'll get to filming like soon. Okay, just got done with the final touches. The board's almost complete. We'll be doing the script. I've got a teleprompter. I just press play, and then as for my phone, just like put it here, put it on something to raise it up, but that's how it's gonna go.